Hello everyone, my name is Robert Penn. In this video, I'm going to walk you through the Solidity code of my Web3 project, which is a decentralized NFT marketplace. Let's go to the GitHub repository. First, inside the contracts folder, we look at the Solidity file of Bored Students NFT, which is one of our NFT collection contracts. At the top of the file, we see the SPDX license identifiers, then the pragma statement for specifying the version of the Solidity we are using. And then we import a bunch of things from OpenZeppelin contracts, including ERC-721 and other features provided by OpenZeppelin. We know OpenZeppelin is an open source library for secure and reusable code, so we don't have to reinvent the wheel. Then we declare our contract with the name Bored Students NFT, and it inherits the contracts from OpenZeppelin by using the keyword is. We know Solidity is an object-oriented language, and the inheritance allows our contract to use other contracts features. Now let's look at the state variables. We know the state variables are stored on the blockchain persistently. Underscore token ID counter is from OpenZeppelin, which is used for NFT's token ID. It is a private variable. That means it can only be accessed inside this contract. Cost is how much you need to pay for minting one NFT, which is in ways. It is a public variable. That means it can be accessed from both inside and outside the contract. And the type of it is an unsigned integer. And then we have the max supply, which is self-explanatory, that we cannot mint more than that. Max mint amount is the max amount of NFTs buyers can mint in one transaction. Time deployed is the time when the contract is deployed to the blockchain. Allow minting after is the time period after the contract is deployed until the time buyers are allowed to mint. These time-related variables are used to prevent buyers from starting minting too early. Then we have two public variables, base URI and base extension, in the string type. They are used to form the URI of the NFT's metadata stored on IPFS. Note that in this project, we use IPFS gateway to make things easier. Then we have two events declared. They will be emitted when the NFT is minted and when the owner withdraws the balance earned. Some parameters are indexed, so they can be used as the filters when we listen to the events from the external app. Then we have a bunch of custom errors declared. Later in the functions, we will check some conditions using the if statements. If the condition is met, we will need to revert the transaction with the custom error. We know it's a more gas-efficient way than using the revert or require function. Then we have the constructor that runs once when a contract is deployed for initializing state variables. Note that for ERC-721 contract we inherited, we also initiate the name of the NFT collection and the token symbol over here. Below are the functions in the contract. We will skip the functions inherited from OpenZeppelin and only go over some major functions. Let's start from the mint function. The mint function takes in one parameter, which is the amount of the NFT's buyer wants to mint. The visibility of the mint function is external. That means the function can only be called from outside the contract. And it's a payable function, which allows buyers to pay Ether to the contract. Of course, in this project it's matic. The first if statement is to check if the mint function is called at the time before we allow buyers to mint. If that's true, then the transaction is reverted with the custom error. The second and third if statements are to check if the amount of NFTs the buyer wants to mint is greater than the limit or below 0. And then in the fourth if statement, we check if the transaction will make the total supply greater than the max supply, which is not allowed to happen. The last if statement is to check if the buyer is sending the correct amount of Ether to the transaction. We know msg.sender is the buyer who calls the function, and msg.value is the amount of Ether the buyer sent. So if we passed all the checks mentioned above, we enter into the for loop for minting the amount of NFTs the buyer paid for. First, we use the feature provided by OpenZeppelin _token ID counter.current to get the token ID for the NFT we are minting. We then increment _token ID counter for the next token ID. Then we use the _SafeMint function in the ERC721 contract to mint the NFT to the buyer. Then we call the getURI function to form the URI for this NFT. Note that in this function, we store the URI in the local variable with data location memory, which will be wiped when the function execution stops. Then we use the _setTokenURI function, which takes in the token ID and URI to set up the URI to the NFT. Finally, we emit the mint NFT event. Next, we look at the withdrawal function. It has an only owner modifier from OpenZeppelin, which means only the contract owner can call this function. First, we get the contract Ether balance using address parentheses this dot balance. Then we use the call function to transfer the balance to the owner. We know the call function is the preferred way to transfer Ether instead of the transfer and send functions. The call function returns a Boolean value. If it is false, the transaction will be reverted with the custom error. And if the call function returns true, that means the transaction is successful, so the event will be emitted.